Good morning students. Dear students, our next topic is welded connection. So what do you mean by welded connection? The process of joining two or more structural members permanently under the application of heat with or without pressure is known as welding. So if the pressure is used for joining the two parts, the process is known as forge welding. If the two parts are joined without any pressure but with a separate weld metal, the process is known as fusion welding. So the figure shows the process of electric arc welding. So in the electric arc welding, as shown in this figure, the intense heat required to reduce the metal to liquid state is produced by electric arc. The arc produces a temperature of about 3600 degrees Celsius, and the tremendous heat at the tip of the electrode melts the filler metal, melts the electrode and base metal, and a molten metal known as crater is formed. This molten metal solidifies into a uniform mass after cooling. Electrode coating, which solidifies as slag, is removed by light tapping after cooling. So then advantage and disadvantage of welded joints over riveted joints. So first advantage, no noise is produced during welding process, but the riveting produces a lot of noise. When the riveting is done, the rivet head is formed by hammering, and hammering causes noise in the process of riveting. So then second point, welded structures are comparatively lighter than corresponding riveted structures. Third point, a welded structure has better finish and appearance than the corresponding riveted structure because the surface is smooth, but in the riveting head of the rivet gives rough surface. So next point, additions and alterations can be easily made in the existing welded structures than in the riveted structures. So next point, maintenance and painting cost for a welded structure is less than the corresponding riveted structures. So sixth point, welded joints have more strength than the riveted joints. Consequently, efficiency of the welded joints is more than the riveted joints. So seventh point, the welded joints are more rigid than the riveted joints. So seventh point, it is possible to weld any part of structure at any point, whereas riveting requires enough clearance. So ninth point, lap length of steel bars in RCC structures can be minimized to a great extent by welding. So 10th point, welding takes less time than riveting. So 11th point, members of such shapes which are difficult for riveting can be easily welded. So then disadvantage. So the members are likely to distort in the process of welding. So because of uneven heating and cooling. So these are the disadvantages. So first point key hai, the members are likely to distort in the process of welding because of uneven heating and cooling. So next point, a welded joints may fail earlier than riveted joint if the structure is under fatigue stresses. Fatigue stresses means repeated stresses. So third point, there is a greater possibility of brittle fracture in the welding than in the riveting. So fourth point, the inspection of welded joints is more difficult and more expensive than the riveted joint. So fifth point, welded joints are over rigid. So sixth point, because no provision is kept for the expansion or contraction in the frame, therefore internal stresses are likely to set up in the welded joints. So next point, skilled labor is required in welding work than in the riveting. So next point is classification of welded joints. So according to their formation, important type of the welds are, first is butt weld, second is fillet weld. So fillet weld, it is also known as lap weld. So first butt weld. This type of weld is used when the members to be connected but against each other. But against each other means touch against each other. The members to be connected, they butt against each other. And the important the type of the butt weld most commonly used are square butt weld, single V butt weld, double V butt weld, single U butt weld, double U butt weld, single bevel butt weld, and double bevel butt weld. So this is square butt weld. So these are the two parts. So these two parts, they butt against each other. So here this is square butt weld. So this is single V butt weld. So two parts are joined by means of butt weld, and the butt weld, this is the shape of the letter V, shape of the English alphabet letter V. So this is single V butt weld. So similarly this is double V butt weld. So one V, second V, this is double V butt weld. So two parts are joined by double V butt weld. So this is single U butt weld. So this is the shape of the single U. This is two parts are joined by single U butt weld. So then this is double. This figure shows two parts are joined by double U butt weld. So one U, second U. So the shape of the weld is double U butt weld. So next is single bevel. This is single bevel butt weld, and this is double bevel butt weld. So then important terms used in the design of butt weld. So first is size of butt weld. Size of butt weld is equal to effective throat thickness. So then effective throat thickness. So effective throat thickness depends upon the penetration of weld metal. So for complete penetration or full penetration. So full penetration of welded metal is possible in case of W, double V, and double bevel butt weld. So in this case, in case of complete penetration or full penetration, effective throat thickness T is equal to thickness of thinner member being connected. So partial penetration or incomplete penetration. So for partial penetration of welded metal occurs in case of single V, single U, and single bevel butt weld. So in this case, effective throat thickness T is taken as 5/8 into thickness of thinner member being connected. So then strength of butt weld. So strength of butt weld means load carrying capacity. So the load carrying capacity of the butt weld is determined by the relation, determined by this relation. Strength of butt weld, this is equal to permissible axial tensile stress on throat thickness, on throat section of butt weld into L into T. So where L is the length of the weld means width of the plate. T is effective throat thickness. So strength of the butt weld, it is given by permissible axial tensile stress on the throat thickness, on the throat section of the butt weld, into length of the weld means width of the plate, into effective throat thickness T, into effective throat thickness T. So thank you.